Good morning, students. Today we are going to see about stepper motor interfacing. A stepper motor is a device used to obtain an accurate position control of rotating shaft. It employs the rotation of its shaft in terms of steps rather than a continuous rotation as in case of AC and DC motors. So here the stepper motor is an electromechanical device that rotates through a fixed angular speed when the digital inputs are applied, and it is suitable for precise position, speed, direction control which are required in automation system. So the angle through which the stepper motor rotates with a fixed angle for each digital data is called step angle, and different stepper motor has different step angle. The more frequently used stepper motor has step angle of 0.9 degree to 1.8 degree. Depending on the sequence applied to the stepper motor, it is classified into two types. That is, one is your 4-step sequence or a full step sequence, and second one is your 8-step sequence or a half step sequence. So here in a dot matrix printer, one small stepper motor which is used to the advance of the paper to the next line position, and a small stepper motor is used to move the print head to the next character position. So in floppy disk, the stepper motor is used to position the read and write head over the desired track. To rotate the shaft of the stepper motor, a sequence of pulses is needed to be applied to the windings of stepper motor in the proper sequence. So the number of pulses required from on complete rotation of shaft of the stepper motor are equal to its number of internal teeth on its motor. So the stator teeth, the rotor teeth lock with each other to fix the position of the shaft. With the pulse applied to the winding input, the rotor rotates by one teeth position or angle x. So the angle x may be calculated as x 360 degree divided by number of rotor teeth. The stepper motor have been designed to work with digital circuits. So the binary level pulses is up to 0 to 5 volt required at its winding input to obtain the rotation of the shaft. The sequence of pulse can be decided depending upon the required motion of the shaft. So the count of the rotation of the shaft of the stepper motor through the specified angle may be calculated with the number of rotor teeth. Okay. So here the calculation is total number of steps. Example, 200 steps is required to complete one rotation, and total number of repeated step. Example, 50 repetitions of sequences, that is 32 hexadecimal. So here let us see the motion step and the excitation sequence for the clock and anti-clockwise rotation of the stepper motor. So how the performance will be in the rotation is clearly visible in this table. So next here we have a problem of designing a stepper motor controller. Write a program to rotate a shaft. So in clockwise there is a 5 rotation, in anti-clockwise there is a 5 rotation. So here the 8255 port addresses 0740H. The stepper motor has 200 rotate teeth. So whereas in port bit A, PA0 drives winding of WA and PA1 drives the winding of WB, so on. The stepper motor has an internal delay of 10 microseconds. Assume that rotation for this delay is already available. So this is a program. So this is also similar to that other interface. So move AL, 80H is to evaluating the 80 values to the accumulator. Next is you are freeing the control word register. Next you are moving AL, 88H. The bit pattern of 88 is moved to the accumulator, and move CX, 1000. Next output port A where you receive the output. So next is your call delay. Next you are decrementing, and then you are initializing the value of CX into 1000. So again you are getting the output in the port A, and this process repeat until it completes a rotation, then end of start. So thank you. If you have any clarification related to this topic, kindly feel free to contact me. Thank you. So before that we have a session. So the code ends, we have to give a code ends, and last is your end of start. So this is the overall program of the stepper motor, and you have a practical session of the stepper motor in the laboratories. If you have any clarification, feel free to contact me. Thank you. Have a great day.